Okay, this video will show how to add the IE2C card, the analog input card, to a project and then set up some logic for it. So what I'll do first is do a new project, so L18 ERM. I'll call this analog 2. I have one expansion module. That's the IE2C card. So over here on the left side, I'll have to go down here to the module, do a right click, new module. I'll type IE2C and select it. It wants a name for it, so I'll call it Module 1. I'll close that. So right now, let's look at the properties for that module and go to configuration. You'll see it's set up for the default. So default settings, 4 to 20 input, 3277 is the number for 4 milliamps, and 16383 is the number for 20 milliamps. So we can change these numbers. Let's change the low end to 4,000 and the high end to 20,000. So that sort of corresponds to 4 to 20, and we'll say OK on that. So what I'll do next is I can go online with the controller and download this configuration and just look at the data coming in. So I have my controller on 1.23. I'll download that. Okay, so let's look at controller tags. You'll look at local 2 input, channel 0. Right now we have 3961. So I have a 4 to 20 current loop simulator, right? It's set on 4, so it's off by about 40. So either my simulator is off or the card is off, but it's not exactly where I expected it to be. So let's run it up to 12 milliamps. It's off a little bit. It's off by about 20 there. If I go to 20 milliamps, it's off by about 78. So it's something's not linear. Okay, it's off by just a small amount. I suppose if I was overly concerned, I would try to write an equation that could flatten the curve and make it more linear. But for now, let's just let that go, because if we divide the raw number by 1,000, we get 20.076 milliamps. And it could be that my transmitter is off a little bit or the card is off, but it's a very small error. Let's roll it down to 12. And again, if I divide by 1,000, I get 12.017. So it's off by about 100th of a milliamp if you look at it that way. So that's not bad. What this is telling me is the card is live, it's working correctly, everything's fine. So let's look at a program that I could write to do something with that. Since I sort of pre-scaled the signal at the card level, I don't have to do much to it. Let's do let's divide by 1,000. So the source will be channel 0 data. Just press enter. I'll divide that by 1000. I'm going to send that to channel 0 MA. Okay. I'll right click. I'll make that a real number. And I will accept those changes. And you'll see that 12.017 milliamps. If I go down to 4.3, that's off by quite a bit. I don't think it was responding there. Let's try that again. Okay, 4.0 on my transducer, 3.96. So it's off by 0.04. So again, I could get data points and come up with an equation to straighten that out, but let's let it go with that. So what can I do with that? Well, let's add a blank line here. Let's add a couple of lines. We'll just do some simple comparison. So we'll say if it's less than 6, let's say, I'll have an output that says less than 6 MA. Okay, that's just a Boolean value. And of course, if I do that, I'll have one that says greater than, just because, and I'll look at the same data source. If it's greater than 12, I'll have an output coil that says greater than 12 MA. Okay, and let's accept those changes. Let's watch it run. So right now it's at 4. Watch the coils there. Go above 6. You're going to go above 12. The other one turns on. So that's about all there is to it. It's supposed to be a linear input. These small errors are either from my transducer, my transmitter, or from the card itself. It's hard to say. Without a calibrated reference source, I can't be 100% sure where it is. I could fix it though with a polynomial curve fit, so I could grab 20 data points and come up with an equation that would straighten it out. So let's try one other thing, I suppose. How about just because we'll do a flashing output. If it's greater than 19, we'll have a flashing output turn on. So let's do a greater than. Look at the same data source, greater than 19. Let's do a timer. So we'll set up a couple of timers here for a flashing output. Just a second to put that together. This can be TR1. This can be TR2. How about half second there, 500? This would be TR1. This would be TR2. And we'll need one other thing, but let me just do one thing at a time. So let's add another line right here. We will look at the TR1, and we'll have an output that says high alarm. Okay, so we're at 6. Let's go up 12, 13, 14, 15, 16, 17, 18. Getting close, getting closer. There it is. and we have the high alarm. So, really a milliamp signal is coming from a transducer. It's either temperature, pressure, level, tank level. It could be almost anything. Distance could be distance as well. And I'm going to turn that raw number into a scaled value. Um, Here I'm looking at straight milliamps. If I want to turn that to, let's say I have tank level, 0 to 100%, what I would do is I would change the configuration at the card level, or I would just leave it at 4,000 to 20,000 and then come up with a compute instruction, just calculate based off of that number. If you do, like for example, if you go back to the configuration on the card, let's just change it. We can change it on the fly. Let's change it to a very low number. Like, I want to put a 0 there, but let's change it to a, no, I shouldn't do that. Let's leave it at 4 to 20. Let's let this be like a, let's just do what I was going to do. We'll do 0 to 100. Okay, not 1,000. So 0 to 100. Let's do that, and let's see what that does to the response of it. So there is 20 mils, 100%. If I scroll down, 12 is 50%, so I'll stop at 12. 50%. If I scroll down to 4, that's 0%, 0. And I'm still going down, like down to 0 milliamps here, and it's showing a negative 25%. So what it's doing is showing percent directly, but in integer values, so it's kind of rough. You lose your precision when you drop your high end that low. So if you made 0 to 1,000, you could divide by 10 and get a decimal point, or so you see where that's going. So you don't want a really low number for a high engineering unit because you lose your precision, unless you just don't want precision. Maybe you just want whole numbers, in which case it's okay. The only problem is that negative. You can't have a negative tank level. So what you could do on that is you could set it, well, you don't want to change it to a 0 to 20, but what you could do is uh, this number right here. Let me show you what you can do here. Add something right here, and it's if if this number is greater than 0, okay, then I will, well, let's do it this way. If it's less than 0, okay, so if it goes negative here, what I'm going to do is put a 0 into that into the value, so I don't really have any negative numbers. So I'll put a 0 into of course this is now tank level, but I'll do that. Okay, so it will catch it before it gets down any further in the program. So let's watch it run here. Okay, so I'm at 0. When I go negative, you see how it doesn't go negative. The result of the division doesn't go negative. When I go positive, it goes back positive. So if I divide by 1 here, let's change it to 1. So I'm not really doing much to it. So now it's percentage. I'm at 0% right there. As it goes up, 12 is 50% right there. And all the way up to 20. 20 is 100%. So let's go negative one more time just to see what happens. Negative 15, I get 0. That's an easy way to stop it from going negative. Just throw in a little bit of a comparison block there. that's all there is to it.